Under the vast expanse of the celestial sphere, a massive scarlet star, one of the most luminous and easily distinguishable stellar bodies, asserts its dominance along the horizon. Situated far beyond our full understanding, this immense cosmic entity possesses the capability of releasing an energy magnitude that could rival the combined radiance of an innumerable array of stars. This astronomical giant, possibly on the verge of an apocalyptic event, may soon unleash an energy burst of such magnitude that it could outshine a billion suns. The real question is, are we prepared for the aftermath such an event could bring? This colossal red star, often referred to as Goliath, resides relatively close to Earth and has emerged as a subject of significant fascination and debate within both the scientific community and the broader public. Recently, this star underwent a considerable transformation, prompting growing concerns among researchers and fueling intense discussions regarding its future trajectory. The most alarming possibility is that this alteration might signal the early stages of a supernova, an explosive stellar phenomenon marking the final phase in a star's life cycle. If Alpha Orionis, the scientific name for this star, were to exhaust its nuclear fuel, it might collapse under its own gravitational pull, triggering a catastrophic explosion. The very thought of such an event sparks anxiety not just among scientists but also for those of us inhabiting Earth, as the potential consequences could be extraordinary. Alpha Orionis, easily recognized by its deep crimson hue, holds the title of being the largest and most radiant star in the Orion constellation. With the aid of advanced tools such as NASA's Hubble Space Telescope, astronomers have closely observed its behavior, particularly in 2019, when it experienced a dramatic loss of mass, a phenomenon that is considered rare for stars of this type, raising alarms across the scientific community. While our Sun frequently undergoes coronal mass ejections, the unusual event witnessed in Alpha Orionis has sparked a re-evaluation of what occurs during the final stages of a massive star's life. Scientists are currently divided over the precise distance of Alpha Orionis from Earth. Estimates vary, with some placing it as far as 1,200 light-years away, while others suggest it might be as close as 724 light-years. The difficulty in accurately determining the position of stars like Alpha Orionis lies in the immense distances involved and the peculiar nature of red giants. Despite uncertainties regarding its precise location, Alpha Orionis continues to captivate observers as one of the most awe-inspiring objects in the night sky, shining several times brighter than our Sun. However, this radiant glow comes at a significant cost. Alpha Orionis is consuming its nuclear fuel at a rapid pace, which accelerates its journey toward the inevitable end of its life cycle. Once it exhausts its fuel supply, the star will likely collapse, possibly forming either a neutron star or, in a more catastrophic scenario, a black hole, depending on the manner in which the explosion unfolds. This leads to a pressing question: could Alpha Orionis pose a threat to Earth? Should a supernova occur within a few light-years of our planet, the ramifications would be devastating. A supernova can release an unimaginable amount of energy, potentially outshining entire galaxies, which presents the possibility of far-reaching consequences, even if Alpha Orionis lies at a considerable distance from our planet. Historically, the last supernova event recorded within our galaxy took place in the year 1604, and since then humanity has not witnessed a similar occurrence on a local scale. However, a significant supernova erupted in 1987 in the Large Magellanic Cloud, located a staggering 169,000 light-years away. Although this explosion had notable consequences for its immediate environment, it posed no direct threat to Earth. Nonetheless, these rare events serve as potent reminders of the immense scale of supernova explosions and the dangers they may present. A supernova, particularly one occurring close to Earth, could create what has been termed a danger zone around the stellar explosion. The risks to life on Earth, however, should be viewed in the broader context of cosmic events. While supernovae are infrequent occurrences, gamma-ray bursts, GRBs, represent an even more potent threat. These bursts are capable of annihilating entire planetary biospheres and flooding them with deadly radiation. For instance, GRBs have the potential to destroy a planet's ozone layer, leaving it exposed to harmful ultraviolet radiation from its sun effects that could persist long after the burst itself has subsided. This looming threat of gamma-ray bursts has become a focus of recent research, shedding new light on the potential hazards associated with stellar explosions that culminate in such dramatic and destructive events. When massive stars explode as supernovae, their brightness can surpass that of entire galaxies. This intensity raises an important question: what would happen if Alpha Orionis were to undergo a similar transformation? Should it explode as a supernova, it could become the second brightest object in the sky, second only to the Sun in terms of visibility. Even at a considerable distance, the energy released in such an explosion might be so intense that it could be visible even during daylight hours. While the visible light emitted by a supernova would undoubtedly be a striking sight, the real threat lies in the high-energy radiation accompanying such an explosion. This radiation, typically in the form of X-rays and gamma rays, would have far-reaching consequences. One of the most pressing concerns is its potential to deplete Earth's protective ozone layer. Without the ozone layer, life on Earth would be exposed to harmful levels of ultraviolet radiation, potentially leading to extinction events. The dangers posed by a supernova do not cease immediately after the explosion. The remnants of the explosion, including shock waves traveling at nearly the speed of light, would continue to pose threats as they spread throughout the solar system. These shock waves could further damage the ozone layer, subjecting Earth to an even greater risk of harmful radiation, which would only heighten the dangers over time. Moreover, the long-term consequences of a supernova's energy release could linger for centuries, leaving lasting damage to the planet. Interestingly, some studies suggest that Earth may have already been affected by the aftermath of a supernova in the past. Elevated levels of iron-60, a radioactive isotope produced in supernova explosions, have been detected in deep-sea sediments and lunar soil, indicating that Earth has likely encountered the fallout from such an event within its geological history, possibly within the last few million years. At present, there are no known supernova candidates near Earth that pose an immediate threat. However, ongoing research is continuously uncovering new potential threats, particularly from supernovae capable of emitting long-range radiation. These supernovae occur when a star nearing the end of its life is surrounded by a massive disk of material, and the shock waves from the explosion interact with this material, creating intense X-ray radiation that can travel vast distances through space. Thankfully, no such candidates have been identified in our vicinity. However, this research has offered fresh insights into the concept of the habitable zone, the region of space where life-supporting conditions may exist. It appears that this zone may be more restricted than previously thought. As astronomers continue to examine the remnants of supernovae, they are discovering that these cosmic remains can give rise to new stars, forming stellar nurseries from the expelled material. This process highlights the interconnected nature of the universe, where the death of one star often leads to the birth of another. In conclusion, while the potential threat of a supernova explosion remains a distant concern for Earth, the study of these events is essential for advancing our understanding of the universe. Supernovae not only provide valuable insights into the life cycles of stars, but they also offer crucial information about the chemical composition of the cosmos and the ways in which galaxies evolve over time. As we continue to explore the vast reaches of space, our understanding of these dramatic cosmic occurrences will deepen, offering a clearer and more comprehensive view of the universe's past, present, and future.